order to multiply rational expressions, the first thing you ought to do is to factor the numerator and the denominator of each rational expression. So I'm going to start with the first rational expression and split up the numerator into two parentheses. That x squared will become x and x. Then we're going to be looking for factors of 8 that subtract to give you positive 2. Well, factors of 8 that subtract to give you positive 2 will be 4 and 2. Because we have a negative sign on the right, we have a sign of each in the parenthesis. We'll want the larger one to be positive here because the middle term ends up being positive. All right, so that's factored. Let's factor the denominator now. So two parentheses. The trinomial here will be split up as x and x. We'll be looking for factors of 20 that subtract to give you 1. Well, factors of 20 that subtract to give you 1 are 5 and 4. And since the middle term is positive, we'll want the larger of those two to be positive, the other one to be negative because we have a difference on the right-hand side. That difference will cause us to have a sign of each in the parentheses. Okay, let's factor the second fraction then. So the numerator of the second fraction is a difference of two squares because this is a square, and we have a difference in the middle. So we'll put the root of x squared, which is x and x. Then we'll have a plus and minus sign, and then 16 will factor into 4 times 4 because the root of 16 is 4. Draw your fraction bar and factor your last trinomial in the denominator. So we have x squared to split up as x and x. This is nice. If it's a positive on the right, we know it's going to be two positive signs because that's the sign on the left in this problem. So we'll do plus and plus. And factors of 4 that add to 5, that will simply be 4 and positive 1. Okay, so we factored our rational expressions. The next thing we need to do is to cancel any like terms. So for example, this x minus 4 can cancel with the x minus 4. Then we're able to cancel the x plus 4 with the x plus 4 above. All right, so it looks like we're out of things that are the same, so we just have to now at this point rewrite whatever's left over. So x plus 4 in the numerator times x minus 2. And then that'll be divided by, looks like x plus 5 times x plus 1. Now, you could multiply that out or expand it out, foiling in other words, if you wanted to, but you don't have to. Our answer is just fine the way it is. All right, let's look at example B then. In example B, we're dealing with division, but that's okay. Division can be turned into multiplication. The way you do that is you recopy the first fraction, or rational expression in this case, and you change division into multiplication. So this becomes multiplication. But when you do that, you must reciprocate the second fraction. So you'll have x squared plus x divided by 7x minus 7. Okay, so we repeat what we did before. We're going to factor and then cancel. So we're going to take that x squared minus 1 and split it up as a difference of two squares. So it'll be x and x plus and minus 1 and 1. Then draw your fraction bar, write your 3x because that's already factored. Okay, let's factor the second rational expression. We're going to factor out an x out of the numerator because that's common to both terms in the numerator. When you take x from x squared, you're left with just x. And when you take x from x, you're just left with 1. So your factoring is x times x plus 1. Draw your fraction bar, and then pull out a 7 in the denominator. That's common to both terms. So I factor out a 7, I'm left with x minus 1 in the denominator. Now from here, we simply cancel and then multiply whatever's left over. So it looks like we have an x here that will cancel with this x. We have an x minus 1 in the denominator here that cancels with the x minus 1 in the numerator there. And it looks like we have x plus 1 quantity squared divided by 3 times 7, which is just 21. And again, you could expand x plus 1 squared if you wanted to, or you can just leave it the way it is. All right, finally, let's tackle example C. To do example C, we want to first work inside the parenthesis, converting that division into multiplication. So we'll have x squared minus 25 divided by x squared minus 3x minus 4. That division symbol will become multiplication, right? Then we reciprocate the fraction next to it. So x squared minus 1 divided by x squared plus 3x minus 10. And on the outside, we still have x minus 2, x minus 5. All right, let's factor and then cancel what we can. So in the numerator of the first fraction, we have a difference of two squares. We'll have x and x plus and minus, and then the root of 25, which is 5 and 5. In the denominator, we'll have the trinomial split up into x and x. We need factors of 4 that subtract to give you -3. Well, 1 and 4 subtract to give you 3, but we want the larger of the two numbers to be negative and the other one positive so that they combine to give you a -3. Okay, then times the x squared minus 1 again is the difference of two squares. So we'll split that up as x and x plus and minus 1 and 1. In the denominator, we're going to break up the trinomial as x and x. We have a negative sign here, so that'll give us a sign of each in the middle. And then we need factors of 10 that will subtract to give you 3. Well, 5 and 2 will do that, and we'll make the 5 the positive one since the middle term is positive, and 2 the negative. Okay, so at that point, we factored everything that's in the parenthesis. Since we're just multiplying, we can go ahead and rewrite what's outside without the parentheses separating them, because essentially now we're just multiplying straight across. All right, so at this point, we'll cancel everything that can be canceled. X plus 5 will cancel with x plus 5. We have x plus 1 canceling with x plus 1. Then we'll have x minus 2 canceling with x minus 2. And then x minus 5 cancels with x minus 5. So when we're all done, it looks like the only thing we have left standing is x minus 1 in the numerator. In the denominator, we have just x minus 4. And that's about as simple as it gets.